Okay, so today we are starting chapter 5. This is a different chapter 5. It's not in our textbook. It's actually from the textbook we used last year. The reason why we're going back and using this chapter is it does a better job of presenting this introduction to the trig because it bases it and does all the calculations based on degrees. Our textbook jumps right into radians. So this will give you a better idea of what's going on, and then we can go back to our textbook for chapter 6 and do everything that we're going to do right now in chapter 5. When we go back to our chapter 6, we're going to do the same thing, but use a different unit of measure. So all of the calculations that we'll be doing in this chapter are going to be using degrees. We are going to be graphing our angles on a coordinate plane. Now, this is sort of tying back to geometry from last year. Last year, when you drew angles or talked about angles, we talked about acute angles, right angles, obtuse, straight. What we're going to be doing in this chapter is we're going to be talking about angles of very large degrees and even angles that are negative. So what we're going to be doing is we're going to be swirling around our axis here to create angles that are greater than 360 degrees. So we can actually draw angles that are both positive and negative. Notice the arrows on our angles, that's going to indicate the direction. So when we have a positive angle of rotation, the side that it starts out on, this is called the initial side. This is our starting point. Where it ends up, where that arrow ends up, is called the terminal side. So when you go to draw your angles and you're drawing them counterclockwise, this will create a positive angle of rotation. Let's say this looks about to be, let's say it's about 40 degrees. This would be measuring a 40-degree angle. If I were to go clockwise and start on my initial side, but now go down, this is going to create a negative degree angle. And this looks like about a 40-degree angle to me. The side where the arrow ends up is called the terminal side. You will sometimes see the Greek symbol there, theta, to indicate the angle measure. Now, if you recall back from your Algebra 1 days, or maybe even pre-algebra, when you had your coordinate plane here, this is kind of wiggly, remember it separated the coordinate plane into 4 quadrants. This was quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Our axis is going to be given the degree measures. So over here, where our initial side is going to be, this starting point is 0 degrees. If I were to create and measure a 90-degree angle, I could come up here, and this would be my terminal side, and this would be a 90-degree angle. Remember the little right angle here. So up top here is 90 degrees. Over here to the side, if I make a semicircle, this would be an angle of 180 degrees because it's stopping on the 180. And then down here, if I go all the way around, 90, 180, and then stop here, this is the 270 mark. And then if I go full circle all the way around, this is creating a 360 degree. So this side over here, it's for both 0 degrees, my initial side, and if I go full circle, it could also be the terminal side when it's 360 degrees. Now, any angle that's in this first quadrant is going to have a measure of 1 degree up to 89 degrees. An angle in quadrant 2 would be from 91 to 179. An angle that ends up in quadrant 3 would be from 181 to 269. And then the last quadrant, 4, this would be from 271 to 359. Most of the time, I'm going to give you a restriction on where I want your answers. And I may say, give an angle measure between 0 and 360. If I don't specify, you could swirl around multiple times. So let's say I wanted to draw an angle that's going to end up in quadrant 2. And let's say I asked you to graph an angle that has a measure of 135 degrees. The way that I would do that is I start here at 0, then I go to 90, and then to get to 135, I need to go 45 more degrees, and I would stop here. Actually, let me make this the terminal side. So this is the initial side where I start, and the blue is the terminal side where my angle stops. So this would be 135 degrees here. And again, you're going to approximate this where you think maybe half of the 90 is, which would be the 45. Let's say I wanted to draw an angle that was 240 degrees. This is going to end up in quadrant 3. So I would come around here, I would go 90, 180, and then to get to 240, I need to go another 60 degrees. So I could say it stops about here, and I could say that looks like my 240 degree angle. Then if I wanted to end up with an angle in quadrant 4, let's say I want to draw in a 330 degree angle. I would go around 90, 180, 270, and then to get 330, again, I need to go 60 degrees more. And that could be my 330. If you want to draw in a negative angle, remember the positive values are these. If you go back the other way, this is really negative 90, also negative 180, negative 270, and then negative 360. And the way that you would do this is you start on your initial side, and let's say I want to make a negative 30 degree angle. I would have my arrow coming down this way, and that could be a negative 30. If I wanted a negative 270, I'd go negative 90, negative 180, and end up here. And that could be a negative 270. So when you want to make a negative angle, you're going to go clockwise. Let's look at a vocabulary word that you're going to see. The word is coterminal. So when you have coterminal angles, they're going to have the same initial side and the same terminal side, but what's going to happen is you're going to go around more or less rotations around the circle. To find these coterminal angles, all we need to do is add or subtract 360 degrees. A lot of times the question will ask to give me a positive coterminal angle to the angle that's given and also a negative coterminal angle. So for example, let's say I graph a 30 degree angle my initial side is here. It's where I'm starting out. And let's say the terminal side ends up here for the 30 degrees. And I want to find a coterminal angle to that 30 degrees. To find a positive coterminal angle, I'm going to take the 30 degrees and I'm going to add 360. A positive coterminal angle will be 390. So what I do is I start out on the same initial. I go 90 degrees, 180, 360, and then 30 degrees more. Notice we started out at the same initial side and we're stopping on the same side. We just swirled around a full circle and then went a little bit more. To find the negative coterminal angle, I take the 30 degrees and I'm going to subtract 360. And the negative coterminal angle will be the negative 330. So we would start on the same initial side, but we go clockwise, negative 90, negative 180, negative 270, and then 60 degrees more. So we end up on that same blue line. We're starting on this same initial and ending on the same terminal. And these are called coterminal angles. Everybody good? Absolutely. Examples. So it wants us to find two coterminal angles, one negative and one positive. Now, I know I just told you before that to get the positive you add 360 and to get the negative you subtract 360. But look at my given angle here. It's huge. So sometimes you're going to have to add or subtract 360 more than once to get to a negative number. So, for example, I could take the 908 and add 360 to get another positive coterminal angle, and it gives me 1,268. That could be my positive one. However, I could also get another positive one by subtracting 360. Because when I subtract 360 one time, I get 548. Notice it's positive. I haven't gotten to the negative yet, so I need to do it again. Once I subtract that, I'm still at a negative, I'm still not there yet. I got to do it one more time to finally get to the negative coterminal angle. Once I do that, I'm finally found a negative coterminal angle. Now, all of these other ones are all acceptable positive coterminal answers. There's an infinite number of coterminal angles. You can keep adding and subtracting 360 as many times as you want. So any one boxed in blue would be good examples of positive coterminal angles, and then the red one would be the negative. Pretty good? Let's try the next one. We're going to do negative 75, the one right below it. So again, to get the negative coterminal angle, I could take negative 75 and subtract 360. And I end up with negative 435 degrees. So there's my negative coterminal. To get to the positive coterminal, take negative 75 and add 360 degrees, and that gives me 285 degrees. And that will be my positive coterminal angle. And again, all three of these are going to start on the same initial side and all end up on the same terminal side. Let's try number 3. Again, to get to my negative coterminal angle, I'm going to take the negative 203, subtract 360, and my negative coterminal angle is at negative 563. To get to the positive coterminal angle, I'm going to add 360, which gives me positive 157. If it asks you for more than one, keep adding and keep subtracting. 699, here's another large one. To get to my negative, I need to subtract 360. However, notice when I do that, I get a positive coterminal. I need to do it one more time to get to the negative. Once I finally do that, I get negative 21 degrees. So again, it's a matter of adding and subtracting 360 degrees. All of these, when you graph them, are going to end up starting at the same spot and ending up on the same spot. The next thing we're going to talk about are decimal degrees. Pretty good? All right, so in geometry, when we measured angles, we always just measured them in degrees. Now what we're going to do is measure things more precisely. And we're going to be measuring them in degrees, minutes, and seconds. Now, some of your calculators have a button that says DMS on it. I noticed on one of the graphing, the scientific calculators this morning, it's just the TI, I think it was the XS30. Instead of the DMS button, it's actually got a picture of a degree symbol, and then it's got like an apostrophe, and then like a little quote. Every calculator is going to be different. On the graphing calculator, you would look for the APP, the apps button, and then when you hit the second key, then it says angle, and then it opens up a menu. And then it's going to let you use your calculator. Honestly, it's almost easier just to multiply and divide by the 60s in this formula, because it almost takes the same number of buttons to push. But just in case you forget what you're doing, sometimes the calculator will help. So just like with time, let's say you're running a marathon, and let's say you want to try to see how much your time improves. Someone who's timing you isn't going to say, oh yeah, you ran that marathon in 2 hours. You want to know a more precise time. You want to know exactly how many hours, how many minutes, and how many seconds it took you to run it, so that way you could maybe improve your time. Same thing here, we're going to measure our angles in a more precise measure. So instead of being hours, minutes, and seconds, the hours are going to be our degrees, but we're still going to have minutes and seconds. When we want to convert our degrees, minutes, and seconds into a decimal degree, we divide by 60. When they give you a decimal degree and you want to convert it to degrees, minutes, and seconds, we're going to multiply by 60. And we're going to see what this means. So let's go ahead and take a look at the next slide. This is given to us. These are the degrees. These are the minutes. And these are the seconds. So These are the minutes, this is the degree, and this is the seconds. So to convert this into a decimal degree, I leave the degree alone. I take the minutes and I'm going to divide them by 60. And then I take the seconds and I'm dividing by those by 3,600. So just like time, there's 60 minutes in an hour and there's 3,600 seconds in an hour. Then you're going to do this on your calculator. Some of your calculators may require you to put these in parentheses. So you're going to do 74 plus 8 divided by 60 plus 14 divided by 3,600. Hit enter. Once you do that, you are going to get 74, see here, 74.137, and then the 2's are going to repeat. So we're going to round this to 3 decimal places. So 74.137 degrees. This has now been transformed from degrees, minutes, and seconds to a decimal degree. Yeah. All right, let's go to number 6. We're doing the same thing. We leave the degrees alone. We take our minutes. Let me try to do the same colors. So 74 stays the same, 165 stays the same. Then I'm going to add 51 divided by 60. And then 9 divided by 3,600. So I'm going to go ahead and key this into my calculator. And I get 165.8525. I'm going to round it, so 165.8523. And these are decimal degrees. For the last 2 examples, we're going to go the other way. And we're going to be multiplying by 60. Everybody ready? Now, this one's a little different. So I'm going to, again, take away my degree. That's going to be my whole number. So 34 degrees. Actually, let me write it down here. Then I'm going to take the decimal portion, 800 or 0.817. I'm going to times it by 60. And I end up with 49.02. The whole number portion becomes the minutes. And then I take the seconds, the 0.02, and I'm going to times it by 60 again, giving me 1.2, which becomes the seconds.
So how come you're not multiplying it by the 3,600?
Because I'm already taking that initial decimal and times it by 60 once. So it's not like a separate thing. We're going to do the exact same thing on number 8. Leave the 59 alone. That is your decimal, or I'm sorry, your degree. So the 59 is the degree. I'm now going to take the decimal portion. I'm going to multiply it by 60. And I get 5.2524. Again, take the whole number portion. That becomes the minutes. Take the remaining decimal portion and multiply that by 60. And you end up with 15.144, and these become the seconds. So when you're answering any of these questions, just make sure that you read what it wants you to round to. Now, on my calculator, like for example, this problem, when I try to use the DMS function, I have to key in the number first, then I hit the second key, then the apps key, then I scroll down, find the DMS on the menu, hit enter, and it gives me this exact answer. So let me show you with my camera on my iPad just to show you. If you forget that you're multiplying by 60 and 360, you can do that as well. So just to show you with my camera here, I can show you the function on my graphing calculator. Let me get the camera. Again, the homework here for 5-1 is due on Tuesday, no school Monday. Your only homework tonight is to study. Make sure your calculator is charged if it's rechargeable, or make sure the battery is good if you need to put in a battery. And remember, you need to show work to get credit for the 7 questions. Each question is weighted the same amount. They're all 6 points each.